Could Earth be in the wrong position within the Milky Way? This question has intrigued human curiosity for centuries. Since we first began exploring the universe, we've come to realize that we are not at the center of anything. We are not at the center of the solar system, not at the center of the Milky Way, and certainly not at the center of the universe. Every step forward in science has taken us further from the idea of this planet's special privilege. Earth is just one among countless planets in the vast cosmos. But is that the absolute truth? Is the solar system's position in the Milky Way truly ideal, or are we simply accepting the place we've been given? To answer these questions, we must first better understand our home, the Milky Way. It is a massive spiral galaxy with a diameter of about 120,000 light-years, an immense size far beyond human comprehension. 1 light-year is equivalent to 63,000 times the distance between Earth and the Sun, and the figure of 120,000 light-years truly makes us feel our insignificance. The Milky Way is not just the host of the solar system, but also the home of hundreds of billions of stars, enormous clouds of gas and dust, nebulae, and countless other planets. The structure of the Milky Way is highly complex. At its heart lies a supermassive black hole, a region of immense gravitational force that keeps stars and matter orbiting around it. The main part of the galaxy is a thin disk about 1,500 light-years thick, where stars, gas, and planets are arranged into bright spiral arms. Surrounding this disk is the galactic halo, a spherical cloud containing globular star clusters, individual stars, and scattered gas clouds. So, where does the solar system lie within this vast structure? Our solar system is located in a relatively quiet area near the inner edge of the Orion Arm, about 27,000 light-years from the galactic center. At the same time, the solar system is about 50 light-years above the galactic plane. This is a rather unique position, not too close to the center to be affected by intense radiation phenomena, and not too far out to be isolated from the materials necessary for the formation and sustenance of life. However, this position is not always entirely safe. Throughout history, there have been astronomical events that subjected life on Earth to harsh upheavals. Some hypotheses suggest that supernova explosions from nearby stars may have caused at least one mass extinction in our planet's history. Yet what is astonishing is that despite such extreme challenges, life not only endured but thrived, creating the diverse and rich world we see today. Is this merely a stroke of pure luck? Or is the solar system's position truly a prime spot within the Milky Way? It's important to remember that each region of the galaxy has its own distinct characteristics. The galactic center, where the density of stars is incredibly high and radiation is intense, may not be conducive to life. Other spiral arms with higher star densities and frequent intense astronomical events may present more challenges than opportunities. Conversely, if the solar system were located too far toward the galaxy's outer edge, isolation from dust clouds and heavy elements might make the formation of life much more difficult. The current position of the solar system provides an excellent balance. It is far enough from the galactic center to avoid the negative effects of strong radiation and energetic explosions, while not so far that it loses connection with the galactic resources necessary for sustaining life. Yet the question remains, is this placement purely coincidental, or has something greater positioned the solar system exactly where it is? We are not at the galaxy's center, but could life exist there? The center of the Milky Way is a strange place, where everything is dominated by a supermassive black hole weighing 4 million times the mass of the Sun. A black hole, by definition, is a region of space where gravity is so strong that no matter or energy, once inside, can escape. However, there is one exception. The gravitational force created by the black hole extends throughout space, influencing surrounding objects and shaping the chaotic motion at the galaxy's core. Supermassive black holes are not uncommon in the universe. Astronomers have discovered that most galaxies, whether small or large, harbor a supermassive black hole at their center. These black holes play a crucial role in controlling the motion of nearby stars. At the center of the Milky Way, millions of stars orbit the black hole at incredibly high speeds. Much like how planets orbit the Sun, but with far more chaotic and perilous trajectories. The presence of a black hole does not automatically turn the galactic center into a giant vacuum cleaner that swallows everything around it. The extreme effects of the black hole, such as the warping of space-time or the complete destruction of matter, only occur within a very small region near it, known as the event horizon. For example, if the Milky Way's supermassive black hole has a diameter of about 1,000,000 miles, the severely affected region would only extend about 10 million miles, minuscule compared to the galaxy's vast size. At greater distances, such as where the nearest stars orbit the black hole, its gravitational force becomes relatively normal. But this is not an ideal location for life to develop. The primary reason lies in the chaotic orbital patterns. Unlike the planets in the solar system, which orbit the Sun on the same plane, the stars around the Milky Way's supermassive black hole move in all directions and planes, creating highly elliptical orbits. Their distances from the black hole can vary by tens of times between their farthest and closest points, leading to significant gravitational fluctuations. For stars with planets orbiting them, these gravitational fluctuations can destabilize the orbits of their planets. Planets located in the habitable zone, where liquid water can exist, may be pulled into regions that are too hot near their host star or too cold far away from it. This significantly diminishes the potential for such planets to sustain life. Additionally, the star density at the galactic center is extraordinarily high. This increases the likelihood of stars passing close to one another, generating powerful gravitational interactions that can disrupt or even destroy the orbits of planets around nearby stars. A planet might be completely pulled away from its host star, becoming a rogue planet drifting in space, or hurled into an uninhabitable zone. Furthermore, stellar interactions could disturb the clouds of comets or asteroids surrounding nearby stars. These objects, when ejected from their orbits, could become significant threats, colliding with planets and causing large-scale extinction events. Even if life begins to emerge on a planet, these collisions could continually delay or entirely halt the evolutionary process. In summary, the galactic center is a chaotic and unstable region where orbits do not adhere to the orderly patterns found in our solar system. Every phenomenon here, from gravitational fluctuations, collisions between objects, to the effects of powerful energy explosions, makes the likelihood of life surviving and thriving extremely low. While Earth's current position in the galaxy may not be the center, it is clearly a much more suitable location than the tumultuous nucleus of the Milky Way.